Hello, YouTube learners, students, and friends. Once again, this is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, Torrance, California. So this is the third video in the series of 1 to 4. This time I'm going to show you C language program algorithm and use of array to convert hexadecimal number to decimal number, and we're going to rely on the procedure and knowledge of hexadecimal numbers that we learned in video 1 and 2. Please watch video 1 and 2 before watching this one. Okay, so here's the C algorithm to convert hexadecimal to decimal. What you do is step number 1 is store the hexadecimal number inputted by the user into a C character array. For that we use the fgets function. So for example, in this step, the hex number 1F41 is stored in a character array will look like below. So as you know, arrays have subscript that starts with 0. So 0, 1, 2, 3, 4, 5, 6, 7. Let's imagine our array was length 7 or more. So since 1F41 has index 0, 1, 2, 3, 1 will be stored in the index 0, F in index 1, 4 index 2, 1 index 3. But what fgets does, it automatically adds a end of line character, and after that it adds a null terminator, and these will be unused array cells. Okay. So in order to convert this to decimal, we need to make sure we don't consider this and this. And the other thing is that user may have entered by mistake a lowercase letter, and our conversion procedure that we are going to use requires to have only uppercase letters. So next is we iterate through only the length of the array that houses the hexadecimal number. So that means we only iterate through before the end of the line character and up to index 0, and convert any lowercase letter user may have entered to uppercase. So if user enters something like this, 1 lowercase f41, we would like to convert it into 1 uppercase 41, and for that we use the toUpper function. What toUpper function does, you can read its description at c++.com, that you pass it a character. If character is lowercase, it'll convert into uppercase and return that value. And if it's not a letter, or if it's okay, so if it's uppercase, it doesn't do anything. If it's a non-letter, like a digit, it just returns that by itself. Actually, uppercase letter also just returns it as is. Okay. So we find the total number of positions or total number of digits in the hex number. This is done C using a function called strlen. So if I take this array, pass it to function strlen, and once again, if you want to know more about strlen, you can read your book or just go to c++.com, type strlen, and that will describe it. So strlen in this case will return 5, 1, 2, 3, 4, 5. And the reason being, the /n is considered as a filled position. Null terminator is not considered a filled position, but /n is. Okay. But when we convert to hexadecimal, We cannot consider this. We have to ignore this one. So we define a variable called largest index that subtracts 2 from the value returned by strlen. So like strlen will return 5 here, but if you go back here, largest index was 3. So we take the value 5 that's returned by strlen and subtract 2 from that. So for this array or this array, largest value of largest index will be 3 because strlen will return 5, subtract 2, and I'll get the 3. Okay. Okay. And next thing we do, which will become more clear when we do the code, we iterate through the array from back to front, starting with the largest index and exit after the last hex digit is processed. So basically what we want to do is this. We start from here. You can always run a for loop to backwards from the largest index in the array to lower ones. Start from here, process this digit, then this, come to here, process this digit, come here, process this digit, finally come here, process that digit. Okay, that's our plan. But there's one little gotcha here that we have to fix. Notice these are stored as characters, not as an integer. Of course, you can store this as an integer anyway. Integer array will not store a character. This character array. So we cannot take these directly and use that to multiply powers of 16 because these are not numbers or integers, these are characters. So next order of business is that we convert each one of these characters into integers, and there is a standard algorithm, but it requires two different algorithms to convert letters and characters that are numbers. This is character that's a letter, character that's a number. What are those two algorithms? When a character is a hex letter, the code to convert that to int is this. We cast the letter into int type. That's going to give us ASCII value. And then subtract 55 from that to get its numeric value on decimal system. We'll show you how this works. Okay. Imagine that hex letter is, digit letter is A. ASCII value of A is 65. So this code that cast letter A into int gives me 65. Okay. But on hex system, value of A is 10. So when I subtract 65 minus 55, that gives me 10. And that gives us 10, the digit value of A in decimal system. So this works. It looks like it came out of the hat, but really it uses the ASCII system, and basically that ASCII value of A is 65. A in hex to decimal is 10. So we just take the ASCII value, subtract 55 for all those digits that are character on or letter. Actually, everything is character, letter on the hex system. So that's one situation. Second is that I could have a character that is a hex numeral, 0 to 9. So in that case, similar thing. First we get the ASCII value by casting that digit into int type, and then we subtract 48 from that. So imagine digit is character 1, ASCII value of 1 is 49, so this will give us 49, and when I subtract 48 I get 1. So you could actually try all the 26 uppercase alphabets and see you're getting the right. Actually, you don't need to do 26 because hex only has A to F. So you can try those, and you can try 0 to 9. So try putting A here, B, C, D, E, and F. Look up ASCII value for this part in the ASCII table and make sure you're getting correct conversion to decimal. You can do the same thing here. That's a hand exercise. If you put 0 here, ASCII value of 0 is really 48. 48 minus 48 is 0. If you put 1 here, ASCII value of 1 is really 49. 49 minus 48 is 1. If you put 2 here, ASCII value of 2 is 50. 50 minus 48 is 2. So this conversion is going to work. So we got that, and in a way, we have accomplished here that this will be 1, this will be 15, this is 4 as it is, and this will be 1. So all these characters got converted into numeric values. Okay? So how do we convert them to decimal? Well, this was the picture before. We said each positional number gets digit multiplied by 16 to the power positional number. So now this picture becomes clear. Once again, 16 to the power 0 will give us 1. 4 into 16 to the power this position number gives us 64. 15 into 16 to the power 2, which is 256, gives us this number, and 1 into 16 to the power 3 gives us this number. Add them all together, we get 8001. So in summary, I can say last digit will get multiplied by 16 to the power 0, 1 before 16 to the power 1, 1 before 16 to the power 2, and so on. And the result of each such multiplication is added to an accumulator, a running accumulator. Once all positions have been iterated through, sum of all contributions will give us the decimal number. And guys, I'm not kidding. You must do this algorithm by hand to understand it. Not doing so will not allow you to understand our C code, which will be our last video in Xcode. And that will be our video number 4. We're going to show you the source code. And everything that we discussed in this video, all these 7, 8 steps, 8th one I didn't show, like summing up, which is right here. You will not understand our source code unless you understand the procedure and this algorithm, and then you'll understand the source code. Okay? So very soon I'll see you in the last video of converting hexadecimal number to C code, to decimal number using C code. Thank you so much.